Hello, this is Miss Cliffner with your video lesson for today. I called it 4.9.4b. It's about how you check for an outlier. So one of the things I wanted to show you is, I'm going to cross off this one where my face is. There we go. If you look at a dot plot like this one right here, right? So if we check out this dot plot and we look and we see there's a whole lot of dots right around here between 0 and 20. And there's a few in the 20s to 30, there's a couple in the 40s, and there's only one that's up here at 65. Let's say this was age ranges at a party. It kind of seems like this dot over here is so far away from the other numbers. Maybe if I was going to add all the numbers and divide by how many, right, to find the mean, there's the mean. Maybe I need to throw this number out because it's so far away from the other numbers. It's outside of what seems normal compared to this data set. So we're trying to figure out mathematically, how can we tell if something is an outlier? So check out these quiz scores, right? Everybody scored between 6 and 10 points out of 10, but one person got a 3. So if I add up all the numbers, it seems like that person who scored a 3 is going to bring it down the average, right? Does that really represent how people did on a quiz? Maybe not. That's what we're looking at mathematically. Okay, so here we go. What I want you to do is draw a line here and here in your notes. So this is what we're looking at. If there's any numbers that's here, I'm going to say the data is okay. Numbers between the lower boundary and the upper boundary are ones that I don't have to throw out as outliers, and I can still include them in finding the mean. Okay, so now I want to look at our data from yesterday. We took notes. And it was about race cars, and we calculated the Q1 and the Q3. So you need to use those numbers today. The Q1 was 235. The Q3 was 255. Now here's the idea. I'm going to use my highlighter. I'm going to highlight these two formulas. These are little math expressions. So this one says Q minus 1.5 times the IQR. This one is Q1 plus 1.5 times the IQR. I'm going to erase my line. I made that too big. Okay, so when I highlight these formulas, I'm basically saying, hey, some mathematicians came up with this idea. If we take the Q1, which is the middle of the lower half, and we subtract 1.5 times the IQR, that's going to create a boundary. And if there's numbers below that boundary, they're outliers. And if there's numbers above the boundary, that would be an outlier as well. So the IQR, remember, was 255 minus 235. So the IQR is right in here. It's the range of the middle half of the data. So 255 minus 235 was 20. This is the example from yesterday. So the IQR is 20 and the IQR is 20. Now I abbreviated. I called it the lower boundary value, LBV. And then there's an upper boundary value, and I'm calling that the UBV. That's up here. So what I want to do is I want to use this formula. I'm going to start off with Q1 minus, which is 235 minus 1.5 times the IQR, 20. Well, 1.5 of 20 is just 30, or you could use a calculator and multiply. 235 minus 30 is 205. So if any numbers in my data set were between 205 and this next number I'm going to calculate, then they're okay. They're all in range. They're not outliers. I'm going to start with 255. This time it's plus 1.5 times 20. So I have 255 plus 30 equals 285. So numbers above 285 or below 205 would be outliers. I'm going to show you the data from yesterday. So 285 is over here. 205 is here. So I'm going to ask you, the smallest number in the data set is 220. It's within that boundary. The biggest number is 270, also within that boundary. So here's how I could type out my answer. Are there any outliers in the data set? I could say no. There are no outliers because no values are below 205, which I'm calling the lower boundary value, or above 285, which is the upper boundary value. So that's how you could type out your explanation. Okay, so now we're going to go and look at, I just have a quick one example, and now we have an OYO. So take a look at this OYO. Here's your data. Does it contain any outliers? justify your answer. So the first thing you do is put the numbers in order, right? This is what your notes say to do. There's the numbers in order. Now, the next thing I need to do is to find the median, the Q1, and the Q3. So I'm going to get the highlighter, and I'm going to work my way to the middle, left and right, left and right. There's 9 numbers, so there's 1 in the middle. That makes that the median. Now I'm going to get a different highlighter color, and I'm going to find the middle of the lower half. See, this divides the data into the lower half. I ignore the 382, left, right. Oops, I'm done. There's 2 numbers in the middle. The middle of 356 and 364, if you can't picture it, you add them and divide by 2. You should get 360. That's the Q1. I'm going to do the same thing with the upper half of the data. Cross off, cross off. I got 2 numbers in the middle. The middle of 396 and 400 is 398. So I take those numbers. Here's what I have, right? I have 360 as my lower middle, 398 as the upper middle, and I have the median. But I don't need the median anymore. I need the Q3 minus Q1. So I do 398 minus 360. This is basically a review of what we learned and how to find the IQR. Phew, I had to do all that. Now I'm going to use the IQR in this new expression, this new formula that I'm showing you. So here it is. I need to take the lower bound, I need to figure out what the lower boundary value is. So I take Q1, which is 360, minus 1.5 times the IQR, which is 38. We just found it right there. So this is 360 minus, if you do this with a calculator, you have to do multiplication first. Remember order of operations? Minus 57, I get 303. So the lower boundary number is 303. Let's go to the next question. It says, hey, are there any data values less than the LVV? The answer is no. So I'm going to write in no values are less than 303. Oops. I want to go back and show you. My smallest number in my list was 350. 350 is not less than 303, right? So that's how I knew that 350, it's a good number in my data set. It's not an outlier. And then I'm going to go and I'm going to calculate the Q3. I'm going to now do the upper boundary. So this is the Q3 that I want to use, 398. So I'm going to do 398 plus, this time it's 1.5 times, it's plus, instead of minus. The lower boundary value, there was a minus there, right? This is the same thing. It's also going to be 57. 398 plus 57 equals 455. So I have to look at the data and see if there's any numbers bigger than 455. I go back to my data. There it is. 368 is in the data set. That number is bigger than the upper boundary. If you have numbers bigger than the upper boundary, they're outliers. So 455 definitely bigger, right? 468 is bigger than 455. So I'm going to say yes, 468 is an outlier because it is more than 455, which is my upper boundary value. Okay, that's how you use the IQR to mathematically prove whether a number in a data set is an outlier. All right, good luck with the homework.